Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for rational exponents, which is a section that is not in your textbook. So all the notes are going to be right here for you. And we're going to do a lot today. We're going to evaluate the root of a number. We're going to rewrite a radical as a rational exponent. And rational just basically means as a fractional exponent. And then we're going to apply some of the properties of exponents, like when you are multiplying the bases, you add the exponents. When you have a power to a power, you multiply. When you're dividing the bases, you subtract. So we're going to apply all those properties to our fractional exponents. And then we're going to simplify expressions and then solve some equations as well. So it sounds like a lot, but it's all connected. And if you feel comfortable with your rules for exponents, and this should be pretty straightforward. But remember that a radical expression is an expression that's written with a radical symbol. So that's your square root symbol. And then you'd have a number inside of it. Okay? And remember that the radicand is the number that's inside the expression. Okay, so the radicand is going to be this little number. And then this little symbol, that's the radical. Okay, so we're still going to see expressions like that today, but so far we've only worked with square roots. And you have to realize that you can take any root of any number. It doesn't just have to be a square root. You could take a cubed root, you could take a fourth root, or a fifth root, or a 10th root. Okay, so this expression that we've seen in the past, this square root of 25, this means we took some number times itself and we got 25. Now we know that that number is going to be 5. X is 5. So we know it was really 5 times 5 is 25. Okay? Now what this expression means then, if you have the cubed root of 8, this means that you would have to take some number times itself 3 times to get 8. So you have to think what times what times what is 8. That what is going to be 2. So 2 times 2 is 4 times 2 is 8. So when you're taking a cubed root, you're multiplying a number by itself 3 times. If you're taking a fourth root, you'd find a number that you'd multiply by itself 4 times to get the radicand. If it was a fifth root, you'd multiply a number by itself 5 times to get the radicand, and so on and so on. So let's take a look at our first example here, and let's see if we can just evaluate these expressions on your calculator, just so we get comfortable with how we would type in these other type of roots into our calculator. Now, you should be able to do the square root of 196. You have a standard square root button on your calculator, okay? And hopefully you know 196 is a perfect square. Hopefully you have that memorized by now after we've gone through the previous couple of sections of notes. So you should know that that's 14. If not, the square root of 196 on your calculator will get you the 14. Okay? Now, if we're going to do a cubed root or a fourth root, like we have here in part B and C, you need a little different key. The key on your calculator might have an X and then the square root symbol. So for this one, depending on the type of calculator that you have, the model that you have, you might have to do 3 and then the button and then 27, or you might have to reverse it and do 27 and then the root button and then the 3. So play around with your calculator and the features that it has. When you take the cubed root of 27 though, you should get 3, because this basically means 3 times 3 times 3 is 27. And 3 times 3 is 9, and then 9 times 3 is 27. Okay, and then for part C, let me switch colors here so it's a little bit easier to see. Again, you want to use that X root button. So you might have to do 4 and then the X root button on your calculator and then the 81. But again, play around with your calculator and see what you get. But the answer should be 3. So if you're not getting 3 when you type in this sequence, you might have to switch it so that you're doing 81 and then the button and then 4. Okay? And again, this means something times itself 4 times gets you 81. And 3 times 3 is 9. And then you've got 2 sets of 9s there. 9 times 9 is 81. Okay? So if you have questions on how to use your calculator, we can address those in class as well. But I want to move on here to this next little note and see if you can notice anything. Okay? We're going to use your calculator now to evaluate these expressions. And notice in example 1, we did the square root of 196. Here we're doing 196 to the 1/2 power. So this is where you want to use your little upside down caret key, or you might have your y to the x key for your exponent. Okay? So you want to do the 196 and then the little caret key or your little y to the x key, and then do parentheses 1 divide by 2, or do your fraction button 1/2. Okay? And when you type that into your calculator, you should get 14. And then we're going to do 27 to the 1/3 power. Notice in part B up here we had 27 and we were taking the cubed root of it. Now we have 27 to the 1/3 power. So again, when you type this into your calculator, you'll want 27 and then your exponent key and then parentheses 1/3, and you should get 3. And then for part C up here, we had the 4th root of 81. Now we have 81 to the 1/4. And again, when you type that into your calculator, you should get 3. So again, if you have questions about how to type that into your calculator to get the right answer, we can address that in class. But the connection I want you to see right here, what do you notice, is that the square root here that we were taking is really our denominator here, 1/2. And the cubed root that we were taking here becomes our denominator here, 1/3. And the 4th root gives us 1/4. So that's our observation, that you can actually rewrite a root or a radical as a fractional exponent. And the root that we're taking is going to be the same as the denominator in our fractional exponent. So we can rewrite fractional exponents, or I'm sorry, we can rewrite radicals as fractional exponents. So how we're going to do that is we can rewrite them basically as what's shown here in this little statement here. Okay? The number inside the radicand is going to become your base, and then it's always going to be 1/, whatever this root is. Now this is assuming that this is b to the 1st power. In a little bit we'll talk about what happens when it's not to the 1st power. And the reason we do this is because sometimes it's easier and faster to type these into your calculator, or to simplify them when they're fractional exponents instead of crazy roots. Okay? Now it's personal choice. They mean the same thing. If you take the nth root of b, that's the same as doing b to the 1/n power. So it's the same thing. So if you like the radicals, that's fine. You can type radicals into your calculator. If you like the fractional exponents, that's fine too. You can type those into your calculator. You're going to get the same answer. But this is a higher level of math now. You have to understand that these are the same. These are equivalent. Okay? So let's practice this a little bit on your calculator. Okay? if you type 125 to the 1/3 power into your calculator, you should get 5. And it doesn't matter if that fractional exponent is positive or negative. Okay, your calculator can still handle it. Now, when we had fractional exponents before, we rewrote them. So we would have moved this whole expression down to the denominator. So when we did this before, we would have had 1 over 81 to the 1/4 power. Now, you don't have to do that. Okay, that's why I'm kind of putting it in parentheses here, like it's in some type of little bubble. You don't have to do that when you're typing it into your calculator. Your calculator can handle a negative fractional exponent. So when you type that into your calculator, though, you'll get 1/3. Now again, you get that fraction, though, because that negative exponent moved the 81 to the 1/4 power to the denominator. So 81 to the 1/4 is 3. So you have 1 over 3. So that's why we get 1/3 for our answer there. Now in part C, this one's kind of funky. Now we don't have a numerator of 1 in our fractional exponent anymore. We have 27 to the 2/3. So don't think that all of those fractional exponents always have to be 1 over something. They can be any number over some other number. But again, your calculator can handle this. Type it in, and you should get 9. So if you're not getting 5 and 1/3 and 9 for those first 3, if you're doing this on your own, bring your calculator into school, into class, and we will show you how to type this into your calculator. Okay, part D gets a little more complicated now because you have a fraction that you're raising to a fractional power. And we're going to see this in a moment, but this is like what we did before, where you kind of distribute that to the numerator and the denominator. So you would have 8 to the 1/3 and then 27 to the 1/3. Okay, again, you don't have to do that. You can just type it all right into your calculator, but you should get 2/3 for your answer. And then part E, this might be a little tricky to read just because of the font on the software here, but this is really 54 over 9 to the 3/2 power. So instead of typing it all as one big string into your calculator, I would leave the 54 for now, and then I would do 9 to the 3/2 on your calculator and get an answer for that. You should get 27, and then you can do 54 divided by 27, which is 2. So as these problems get more and more complicated, it's okay to have multiple steps in these problems. And if you do the multiple steps in your calculator, that's okay. You're just not going to have a chance of making as many errors. Students who type this all into their calculator the way it looks are going to run the risk of making an error instead of people who are very cautious and do one step at a time. Okay? Now, if you look at part C, I believe it is. Part C in example 2 here. I said that we have a fractional exponent that doesn't have a 1 in the numerator. Okay, now this denominator still tells me what root I was taking. So we had 27 to the 2/3. So really that means I was taking the cubed root of 27 squared. That's really what that means. And this is another way that we can rewrite our expressions with fractional exponents. We can go from the radical to a fractional exponent, or from a fractional exponent back into a radical. We can rewrite them in either direction. Okay, so when your base has an exponent on it that's other than 1, that exponent becomes the numerator, and the root still is the denominator. So sometimes that m value might be a value of 1, and then we would have had 27 to the 1/3. Okay? But if it's not a 1, that means that that numerator is going to stay as your exponent with your base inside the radical. Okay? So let's practice rewriting some of these expressions because this is an important skill that's going to help us with our last few examples. Okay, so rewrite the square root of 49. Now I know the square root of 49 is 7. We know that. So I picked this on purpose because it's one that you're familiar with. So anytime you have a square root, remember there's a little invisible 2 that's there. It just doesn't get written in. Okay? Math people are lazy and they don't like to write in the little 2 if it's just a common square root. So really this means we have 49. And 49 has a power of 1 here. This is 49 to the first. So it's 49 to the 1/2 power. And that you can type into your calculator and you should get 7. So if you type in 49 to the 1/2 or if you type in the square root of 49, you're going to get 7. For this problem, I think it's easier to think of it as the square root of 49. You're more familiar with that. But you need to know that it's the same thing as 49 to the 1/2 power. Okay, for part B, we have x, and it's really x to the first. So if I rewrote this, this would be x to the 1/3 power. The root that we take becomes the denominator in our fractional exponent. And the exponent, if we have one, on the radicand becomes the numerator in our fractional exponent. Okay. Now for part C, this one is tricky. This is the one that students miss the most often. And that's because they don't realize that you have a 16 and a y inside your square or your fourth root here. Okay? So we have 2 terms that we're taking the fourth root of. So you're going to rewrite it 2 ways. Okay? We're going to have the 16y, and then we're going to have the whole expression to the 1/4 power. So if I'm taking the fourth root, it's like doing a 1/4 power. And the 16 and the y both have 1 for their exponents. And then I'm going to basically distribute that to both terms. So I'll have 16 to the 1/4 and y to the 1/4. And that should be a familiar concept. We've distributed exponents to everything that's inside the parentheses in the last chapter. And the reason we want to do that is because now I can evaluate 16 to the 1/4. Okay? 16 to the 1/4 is 2, and then the y to the 1/4, I'll just have to leave y to the 1/4. But 2 is a lot easier than saying 16 to the 1/4. Okay? So if you have multiple terms inside that radical, make sure you distribute the fractional exponent to everything that's in that term. Okay, example 4 now. This is where we're going to talk about some of the rules for exponents that we've talked about in the past in the previous chapter, in chapter 9. They still apply to this stuff with fractional exponents. Okay? So in example 4 here, for part A, we have x to the 1/2 times x to the first times x to the 5/2. So remember, if there's not an exponent there, it's to the 1 power. And when you're multiplying the bases, the rule is that you add the exponents. So that's what we would do here. We would take 1/2 plus 1 plus 5/2. Okay? And 1/2 plus 5/2, that would be 6/2. 6/2 is 3, plus this other 1 is going to be a 4. If you can't do that mentally, then do it on your calculator. So basically we have x to the 4th power. Let me simplify. You want to keep your base as an x. Don't write 3x. Remember, that was a concept that some students were messing up on in the previous chapter. You don't multiply the x's together. You just leave it x, and you add the exponents. For part B, this is where we're going to distribute. Okay, we have a term here inside our parentheses, and it has multiple parts to it. It has a 4, and then it has a b to the 5/12. So we're going to take this 3/2 and we're going to distribute it to both of them. So I'll have 4 to the 3/2 times, I'm going to write this in parentheses, b to the 5/12 to the 3/2. So this 4 to the 3/2 that I can do on my calculator, that should get you 8. And then for the b, here I have another exponential rule. I have a power to a power. So when that happens, remember, you multiply. So I'm going to take 5/12 times the 3/2. You can do that on your calculator, and you should get b to the 5/8. Now the calculator won't put the b in there for you, but if you do 5/12 times 3/2, it'll get you 5/8. So distribute that exponent that's outside the parentheses to each term, even when it's a fractional exponent. And then you can simplify each part. Okay. For part C, we're dividing our bases. So when you're dividing the bases, remember you want to subtract your exponents. So 5/3 minus 2/3. Hopefully you don't need a calculator for this because the denominators are the same. So 5 minus 2 is 3. Okay, so we're going to do 5/3 minus 2/3. That's 3/3, which is really 1. So here we would have y to the first power, or just y. You could write it either way. Either way is correct. Okay, for part D, I kind of saw this earlier in the notes when we had a fraction in example 2. And you should know that even when you have a fraction and you have an exponent outside of it, you're going to distribute that fractional exponent to the numerator and the denominator. So we'll have 256 to the 1/4 power and 625 to the 1/4 power. Now these you want to do on your calculator. And 256 to the 1/4 power, that's going to be 4. And 625 to the 1/4 power, that's going to be 5. So you have 4/5. Okay, part E has a negative exponent. Now, if this was just numbers, like if we didn't have this variable z as our base, you could just put this into your calculator and evaluate it. But since we don't know what z is, we have to apply that rule where when you have a negative exponent and it's in the denominator, you have to move it up to the numerator and make it a positive exponent. So this is like what we talked about when you have bird poop on the windshield of your car. You got to take it through the car wash and get it all nice and squeaky clean. So now I'll have 1 times z to the 2/5. Or you could just have z to the 2/5. Okay, so those rules for negative exponents still apply. If it's negative in the numerator, move it down to the denominator. If it's negative in the denominator, move it up to the numerator. Okay, now part F, we're going to do 2 rules here. This is where in the numerator, we're multiplying the bases. So we're going to add our exponents. So 1/6 plus 1/2. Do that on your calculator if you need to. You'll get n to the 2/3. And then we have n to the 1/3. Now to finish simplifying here, I'm dividing my bases. So when I divide my bases, I subtract. So 2/3 minus 1/3 is 1/3. Okay, so you need to be comfortable with getting fractional exponents for answers too. Sometimes students see this n to the 1/3 and they think, oh, I've got to move it to the denominator. I've got to move it up because it's a fraction. That's okay now. You can have fractions in your exponents. Okay, so all these rules from the past with exponents still apply when we have fractional exponents. Okay, let's talk about one last concept here, and then we're going to move on to some equations. For example 5, it says use rational exponents to evaluate. How would you do this? We've got two radicals here, and they want us to use rational or fractional exponents. Well, we're going to have to rewrite them. We're going to have to rewrite 12 and the square root of 12 and the fifth root of 12. So remember, this is a square root, so there's a little 2 there. This 12 doesn't have an exponent, so it's 12 to the first power for both of them. So if I'm going to rewrite this, this first 12 is going to be 12 to the 1/2 power, and the second one is going to be 12 to the 1/5 power. Now I'm multiplying my bases, so I know I can use the rule where I have to add my exponents. So I'll do 1/2 plus 1/5. And do that on your calculator if you need to, and you'll get 12 to the 7/10. Now you don't have to evaluate that. You don't have to do 12 to the 7/10 and get some sort of fraction or decimal in your calculator. Just leave it 12 to the 7/10. 12 is your base, 7/10 is your power, or your exponent. It's probably going to be some crazy decimal answer anyway that's going to be really awkward and inconvenient. So just leave it as a exponent. Okay, last concept then has to deal with solving equations. And we're going to deal more with equations later on in the chapter, but we wanted to talk about the fractional exponents and how you can solve those equations. Okay? So if you were going to solve this expression here, if you had x squared equals 16, remember that this x squared really means you're taking x times x. You're taking some number times itself to get 16. And hopefully you know that 4 times 4 is 16. So we know that x is going to be 4. Okay? There's another way to do this though. The opposite of squaring something is to take the square root of it. And the square root of 16 is 4. Okay? So we need to be aware of that concept of opposites here. So if we're looking at this expression, or I'm sorry, this equation, we have x to the 1/2 equals 5. That's harder to write out. I don't know how to write x to the 1/2 like I did up here. I could do x times x. I don't know how to rewrite that. I really can't. Okay? But I need to figure out what could I multiply 1/2 by to pretty much undo it. Okay? And by undoing it, I mean 1/2 times something equals 1. Because once you've done an opposite to something, they cancel each other out and you just get 1. So if you have 8 and negative 8s and you're adding them together, okay, they cancel each other out. Okay? So here, what would I have to multiply by to get the 1/2 to cancel out? And that would be a 2. So I'm going to square both sides of my equation. Because 1/2 times 2 is 1, so I get x to the first power. And then 5 squared, oh, I can do that, that's 25. So x is 25. So basically, if you want to undo that fractional exponent, you are multiplying by the denominator, in a way. And then that's going to become your new exponent. So it's not really so much multiplying as it is making that a power. So you're going to do a power to a power there. Okay, so let's take a look at our last example here. Let's work through some of these equations. Now the thing is, you have to get the variable by itself. If it says to solve for the given variable, you have to make sure the variable is by itself first. Okay? So for part A, I'm going to eventually be solving for this v. Right now it's v to the 1/3. So I've got to get him by himself, so I have to add the 5 over. So I'll have v to the 1/3 equals 5. Now to get rid of that 1/3, I'm going to cube it, because 1/3 times 3 will be 1, and the denominator is 3. So I'll have v equals 5 to the 3rd. Now you do in your calculator, that's 125. Okay, for part B, we're going to rewrite it just a little bit first so that we have our fractional exponent. That way I know what I need to multiply by to undo it. So this is the 4th root of t, and that t is what I'm going to be solving for. Right now, remember, it's t to the 1st power. So if I rewrote this, this would be t to the 1/4 equals 2. So to get rid of that 1/4 power, I'm going to raise it to the power of 4. Because 4 times 1/4 is 1. And then 2 to the 4th power, that'll be 16. Now you could double check this. You could put 16 in there for t, and you could take the 4th root of 16, and it should get you 2. Okay, part C, last one. Eventually I'm going to be solving for this x, but right now it's the square root of x. So I have to subtract that 8 over. So I'll have the square root of x equals 15 minus 8 is 7. Okay. Now, this means that I took the square root of something and I got 7. So hopefully you know that that something has to be 49, because the square root of 49 is 7. So that's going to be my answer. But I want to go through this middle part here where we rewrite it, because this is a square root of x to the 1st power. So this is really x to the 1/2 equals 7. And then to get rid of that 1/2, I'm going to square it. And then 7 squared is 49. Okay? So when you see squaring and square rooting, they're going to be opposites of each other. They undo each other. So here you could just leave it as a square root and then square both sides of the equation. Okay, so I could have done the squaring step right here. I wouldn't have had to rewrite it. But I want you guys to rewrite it so that you get practice with those fractional exponents. Okay? So closing notes then, or conclusions, is that radicals can be rewritten and they can be rewritten as fractional exponents. I'll abbreviate that. Okay. We can also do these on our calculator, which is good. All the rules for exponents still apply. So all those exponent rules for whole number exponents still apply to the fractional exponents. And the whole reason for doing this is that sometimes you can solve an equation faster when you use your fractional exponents. Now, I know you guys are probably going to think that it's not faster, but remember, this is still new to you. You're still learning this. So it's going to be a little bit slow of a process while you're learning it. Once you understand it and you get really good at it, it does go really fast. Okay? And even if it's not a faster way to do it, it is another way. It's another way to solve the problem and get the same answer. So tonight's homework then is going to be the rational exponents worksheet. All of these concepts from your notes are going to be on there. Definitely use your notes as a guide. And if you didn't get a copy of the worksheet in class, it's also on the class website for you to print off. And if you have any questions, please, please, please come and see me before school.